Hey everybody, Mr. Longo is back to talk to you about an infinite geometric series. Now, infinite geometric series sounds really complicated because we're supposed to be thinking about infinity. So if we think about infinity, we know it goes on forever and ever and ever and ever. So how in the world would it ever be possible to find a sum of an infinite series? Well, what we're going to be doing is we're going to be talking about partial sums. So partial sums is we're going to find the sum of the first n number of terms of an infinite series, and we're going to basically find out if they approach a certain limiting term. And that limiting term is known as L. And instead of doing these step by step, which would make this video extremely long, I already have everything worked out for you. So this video is mostly going to be me talking. And then we're going to try 4 examples, and we will be done. So, with a geometric series, we know that we're going to be adding a whole bunch of terms, but these terms have common ratios, which means we're multiplying. So I'm going to compare 2 different ones. Both have an initial term of 1, but one we have a rate of 2, and another one we have a rate of 1/2. And we're going to see what happens. So if we were to just list out the first 5 terms of each, 2 raised to the n power would be 2, 4, 8, 16, 32. And of course, they would both start at 1 because everything raised to, whatever. But this one, we're only looking at the couple of terms starting from here, just so we can see what's going to happen. So if we were to just take the first term, it's 2. If we were to add the first 2 terms, it's 6. If we were to add the first 3 terms, we'd have 14, and then 30, and then 62. And what we see is happening is it is just going to increase and increase forever and ever and ever, because we're just going to keep on multiplying by 2. So we're going to reach an astronomical number very, very quickly. So if it keeps on rising and rising and we have no number it's approaching except for infinity, that's when we know our rate, or the absolute value of our rate, just in case it's negative, if it's greater than or equal to 1, it's going to diverge, which means we're not going to be able to find the sum because it's never going to approach a certain number. So now let's go turn that into a 1/2 and do the exact same thing. If we were to take 1/2 and raise that to the first power and then the second power and come up with all these terms and then add those, we're going to find something different happens. So 1/2 is obviously 0.5. And we add a 1/4 to that and we get 0.75. We add an 1/8 to that and we get 0.875. We add a 16th to that and we get 0.938, and then we got 0.969. And as we were to keep on going, you'll notice that you're adding such a small amount that you'll actually never get to 1, but you'll get very, very close to 1. You'll get 0.9999999, and what that means is we are converging on the number 1, meaning we will never get to a sum of 1. But the absolute value of a rate, if it's less than 1, it will converge to a certain number. And that number is what we call L, which represents the sum of an infinite series, and we find that by taking the first term and we divide it by 1 minus our rate. Okay? And really that's all we need to do. So if we find that our rate is bigger than 1, we just say it diverges and there's no sum. If we do have a rate that's less than 1, then all we have to do is substitute it into the formula and we'll be good to go. So let's do the first one together. We have an infinite series, which has an infinity at top. That's how we know. 3 is our first term. 0.7 is our ratio raised to the k minus 1. So we just need to find the sum of an infinite series. So to do that, remember, our formula is our first term divided by 1 minus our rate, or our ratio of 0.7. So that's equal to 3 divided by 0.3, which is 10. So L is equal to 10. That's the number it converges to. And we're going to be really, really close to 10. In our next example, our rate is 5/4, which is greater than 1. So this one has no sum. And it's because the series diverges. Okay, that's just going to keep on getting bigger and bigger and bigger and continue to go into infinity. So the next two examples are for you to try. Press the pause button, try both of them. When you're ready, click play. The first thing you have to do is obviously find the rate of the first one. And the second one, the rate's already given, so it's just extra practice. Go give these two a shot. Okay, so to find the rate, remember, when we find rates of geometric sequences, it's the term divided by the term before it. So 3/4, or negative 3/4, divided by 3 is going to give us a ratio of negative 1/4. So then we're just going to take our formula, our first term divided by 1 minus our ratio of 1/4. So that's going to give us 3 divided by 1 minus a negative 1/4 is going to give us 5/4. So L is equal to 3 divided by 5/4 is 12/5. Okay, so our sum of that infinite geometric series is going to approach 12/5. And the last example should be the same thing. Our first term is 1. Whenever there's nothing here, we have to imagine that the first term is 1. Divided by 1 minus our ratio of negative 1/2. So that's going to give us 1 divided by 1 plus 1/2 is going to give us 3/2. So we're going to find that L is equal to 1 divided by 3/2, which is 2/3. Okay? So that's it for finding sum of infinite series. This is Longo and I'm out. See you, bye.